Okay, everyone, and this is my channel about the physics. So, because I'm a high school teacher, so I want to share some syllabus about the compulsory physics. And when students graduate from the junior high school, they will maybe have some knowledge about the physics. However, said when they enter the high schools, there is some basic knowledge is not enough for us to handle the physical years or even the 3 years of the high school. So now I want to start the introduction about this is our syllabus about compulsory physics. So which of you can enjoy the compulsory physics and do it well. So the first of all, we want to here's the chapter 1, and the chapter 1 is the introduction. And we know that the introduction actually is full of lots of things. Is that, for example, what is physics? Okay, so what is physics really? Actually, very fancy because that the physics actually we're talking about we want to describe the motion of the object. Okay, so there's a lot of there's other science like the biology, chemistry, and geographies and others information. But however, the physics actually is based on the philosophies and also have lots of things can help us to we use we stop everything from the math. So actually, if you want to run the physics well, you also have good wells in the mathematics. So the first we will introduce what is the physics and also the physical trinity. And unit. So as a scientist, if you want to share something you already knows to others, and however the others actually foreign and they don't know the language, so you must have the common language. And I often say that the common language actually is the physical quantity and the units. Okay, so the first one, chapter 1, actually just an introduction about the physics in high school about compulsory physics. Okay, so the chapter 2, we're talking about compositions of the matters. And we all know that everything is the nature. There are lots of things in the natures. Maybe the volatics, pens, or bacteria, or maybe the virus. So all these things compose of nature. However, the fundamental and the origin of the matter, what is it? So the chapter 2 we're talking about the composition of the matters. So we will know the structure about the atoms, all the and molecular particles. Okay, so all these will be great. And also, this kind, the chapter 2 is really great. And when we finish off this, we'll skip to, and we also will learn some microscopic structure about the atoms and molecules, including we will know the fundamental elementary particles like the neutron, electron, and the neuron. I'm sorry, the patrons. So all these elementary particles compose models of the models of the atoms. And when we finish the composition of matters, we're talking about the motions. So if we want to know some language about how to describe the equation of motion. So the motion, maybe you can describe the motions. So maybe you will learn some velocities and displacement, speed, and distance in these chapters, and also you will know the capillars. Another is the celestial motion. And celestial motion is that the planets in circles around the maybe Earth or maybe the Sun. So this is what we call the celestial motions. And we were talking about a man who codes the capillars. And the capillars propose rules about the capillars laws. And the capillars are actually including the 3 laws. And all this is concluding from the data of the tables. So I think the really interesting part, the most interesting part in the classical physics. Okay, so and when we finish the chapter 1 to chapter 3, we went to the next chapter 4 about the integration of magnetism, electromagnetism. So actually in the past, the scientists think that the charge is a charge, and the charge will cause the electric force, and the moving charge. Is the current. Okay, so the charge is the electric force, and the moving charge causes the current, and also the current will cause the magnetic force. So the magnetic force, actually the magnetic field. So here there is another thing we got to talking about, that is the field. What is the field? And I think the field actually is affected a scope, a space, or maybe a space affected by the force. That would be great. Okay, so we will finish the chapter 4, and we will get to the talking about energy. So the energy actually is a force of the work and the energy type. So including the mechanical and the heat energy, and also the nuclear energies. So here we are talking about some conservation about the energies, and we're talking about the nuclear. I think the nuclear energies will be more interesting for lots of people. Okay, so and the finals we were talking about modern physics. So the modern physics, actually we can classify into the 2 parts. The first, the modern physics, and the classical physics. So the modern physics, which mean that is the classical physics is more simple for lots of person that they didn't know. And however, the modern physics actually we focus on the microscopic scale will be lots of difference about this. And the classical physics is much appropriate for the planets, like the planets or other things we can use the eyes. We can use the eyes to observe the naked. So I think that this sixth chapter is really important for all of us in the compulsory physics, and I will more. Actually, the most topics I want to teach will be the final chapter 6 about the modern physics, because if you want to understand the modern physics well, and there's lots of the mathematics you must learn. However, you want to know, actually these topics will be lots of the historic story about the scientists. So I think that's great. So this is my syllabus about the compulsory physics. So let's just let us start to the chapter 1 and start our compulsion of physics.